In this video, we are going to focus on ionic compounds. So these are compounds that have atoms that are attracted to each other electrostatically. So that means anion and a cation are attracted to one another by the opposite charges being attracted to one another. Um, and so that is our definition of an ionic bond in its most fundamental form. So that we have oppositely charged ions that are attracted electrostatically, and they form that ionic bond, which is that attraction. I disagree with most textbooks that try to simplify this and say that an ionic bond is a transfer of an electron from one atom to another, creating these charges, this positive and negative. So it would say that the ionic bond actually forms from sodium losing one of its electrons and giving it to chlorine in this spot here. And that is a way that they can form. It's definitely true. But that act of the electron transferring is a reduction in oxidation reaction that we'll talk about in detail in this class. And then later on in our year, we'll spend a lot more time with it when we talk about electrochemistry. But it is a fantastic segment of chemistry. And I think it's ridiculous to oversimplify an ionic bond to redox reaction, because it's not like we can have something that's already charged, and if they come into the presence of one another, they can form an ionic bond without transferring an electron. It's just anything that's charged oppositely will be attracted to one another. And it's really Coulomb's force, right? Or Coulomb's law that dictates that. And we'll talk about Coulomb's law some more too. So it's not a transfer of electrons. It's an electrostatic attraction between an ion, a cation and an anion. And this is important to note, that all answers that say it's a transfer of electrons is an ionic bond will be wrong on any form of assessment that I do. So heads up. All right, but once you have something that's positively charged and negatively charged, that opposite charges they attract, and then we have an ionic bond between them. So predicting ionic charges can be simplified to some simple rules for most of our main group elements. But anything here that you see without a charge on it, these are all elements that can have multiple charges. And so that means that they might have one that's most common, but you would have to kind of memorize that. And there's a rule set for determining it that we'll learn when we go deeper into the electronic structure of an atom. For now, we're going to focus on the simple rule, which is that for anything that has a positive charge, the charge will be equal to the group number. So that means everything in our first group will have a +1 charge. Everything in our second group will have a +2 charge, and aluminum in our third group will have a +3 charge. So cation charge is equal to its group number. For anions, the charge will always be equal to 8 minus its group number. And our anions are going to be our nonmetals and tellurium, which is a metalloid. And so for all of these, the charge of our anion is going to be 8 minus that group number. So for our halogens, we have a group number of 7. So it's always going to be 8 minus 7. They'll all be -1. Or sorry, it'll all be 1, but the charge is negative. So this equals 1. And since it's non-metal, it'll be an anion. So it'll be -1. If it helps, the other way to think about it is to do the group number -8, gives you the sign and the magnitude. So group 6 will always be -2, and group 5 will be -3. So here's how we can predict the ionic compounds that will form from certain elements, especially ones with predictable charges. So if we're just given aluminum and oxygen as our elements, and it's like what ionic compound would form from that, we are going to need to balance our charges so we have an overall neutral compound. So a most stable arrangement will have a charge of 0 for the compound. And so our cations and anions will add together in a ratio and form ionic bonds in a ratio that get it to a neutral 0 charge overall. So what we're going to do is first identify which element is the cation and which is the anion. And then we're going to determine what charges they are. So for aluminum, it's in group 3. It's a metal, and our metals are typically cations, so it's going to have a +3 charge. And our oxygen is a nonmetal, so it'll form a negative charge. It'll be our anion. It's in group 6, so 8 minus 6 is 2. It'll have a -2 charge. All right, so now we need to figure out how to combine these in a way that we have an overall charge of 0. If it's, sometimes you could just do this by looking at it. Like if you have sodium with a +1 and chlorine with a -1, you're like, it's the same but opposite, so it'll be a 1-to-1 ratio. If it's less simple, what we're doing is effectively trying to find the lowest common denominator that would work for both. And in chemistry, we have a little silly way of doing this called the Crisscross Rule. And so what we would do is whenever we have something like a +3 and a -2, which might take a second to think through what ratio that would be, we are going to use that magnitude of the charge. And when I say magnitude, I mean the number. So the magnitude of aluminum's charge is 3, and the magnitude of oxygen's charge is 2. So I'm going to use that magnitude as my ratios. And so that's on the opposite atom. So my 2 minus charge of oxygen is going to become a magnitude of 2, and it's going to be 2 aluminum atoms. And that 3 is going to become a 3 oxygen atoms. And we can double check this now, right? If I have 2 aluminum atoms with a +3 charge, I have 2 times +3 for a total of +6 charge coming from my aluminum atoms. If I have 3 oxygen atoms, each with a -2 charge, it's 3 times -2, which will be -6 total charge from my oxygen atoms. When I add these up, I get 0. And so that's the goal, is we want the total negative charge and the total positive charge to be equal to get to that 0 overall charge. So my chemical formula for this is aluminum 2 and then 3 oxygens. Also, I should point out, since we're talking about ionic compounds, we've been talking about order for writing chemical formulas, we always write the cation first for a ionic compound.